Welcome to Moo Techie, where we bring you detailed and practical knowledge in dairy science and technology. In today's Class 11, we will thoroughly explore the mammary system, milk secretion, and milk letdown process, breaking down each and every point to ensure a complete understanding. Let's begin. We start with the title of today's class, Class 11, focusing on the mammary system, milk secretion, and milk letdown. Now let's look at the introductory overview. The udder of a cow is a highly specialized organ designed to produce and provide milk to the newborn calf. Its development begins during fetal life, and once the animal reaches puberty, hormonal surges significantly accelerate the growth of the mammary gland in relation to the rest of the body. After parturition, the mammary tissues continue to proliferate, and milk secretion increases rapidly. The secretory cells reach their peak activity just a few weeks after birth. It is important to note that the entire process of milk secretion is regulated and controlled by several key hormones. Structure and function of the mammary system. Moving forward, we will examine the structure and function of the mammary system. This includes a detailed look at the anatomy of the udder, its internal structure, and the physiology behind its function. Next, we see that the udder is composed of 4 separate glands, commonly referred to as quarters. The front quarters account for approximately 40% of the total milk production, while the rear quarters are responsible for the remaining 60%. The mammary system consists of several major components. First, the support system, which includes ligaments and connective tissue that provide structural integrity. Second, the secretory and duct system, which functions as an exocrine gland to produce and transport milk. Third, the blood supply and capillary structures. It is fascinating to note that to produce just 1 kilogram of milk, between 400 and 500 kilograms of blood must pass through the udder. Fourth, the lymph system plays a role in maintaining fluid balance. Fifth, the innervation of the udder is crucial, particularly for the milk letdown reflex. The support system is made up of the lateral suspensory ligament, the median suspensory ligament, the skin, and the teat. Each of these elements works together to maintain the shape, position, and stability of the udder. Now we delve into the secretory and duct system. This includes alveoli, which are small sac-like structures, lobules that contain clusters of alveoli, connective tissue that offers support, major ducts that transport milk, the gland cistern and teat cistern which serve as milk reservoirs, and the teat meatus, which is the opening through which milk is expelled. The diagram also highlights lobes, alveolar epithelial cells, the lumen of the alveolus, intralobular and interlobular ducts, lactiferous ducts, and the teat canal leading to the teat orifice. Additional visual details are provided to enhance understanding of the system structure. Key parts are labeled for clarity. The alveolus, where milk is produced, epithelial cells that line the alveoli, lobes comprising multiple lobules, muscle cells that aid in milk ejection, blood vessels supplying nutrients, the gland cistern storing milk, Furstenberg's rosette, a protective structure at the teat base, the streak or papillary canal, the location of the keratin plug which helps prevent infections, and the external teat orifice. A detailed table illustrates the transformation of blood constituents into milk components. For example, water, minerals, and vitamins pass directly into milk. Immunoglobulins provide immunity. Amino acids are converted into caseins, and glucose is used to produce lactose and triglycerides through various metabolic processes. Milk secretion and letdown. We now focus on the hormones involved. Oxytocin is responsible for milk letdown, while prolactin is essential for milk synthesis, production, and the maintenance of lactation. The process of milk secretion and letdown begins with stimuli such as calf suckling, udder washing, or hand milking. These signals are sent to the brain, which in turn triggers the posterior pituitary gland to release oxytocin into the bloodstream. Oxytocin then causes the myoepithelial cells surrounding the alveoli to contract, pushing milk into the gland cistern and teat cistern, making it available for removal. A diagram shows the involved anatomical structures, including the adrenal gland, spinal cord, brain, posterior pituitary gland, epinephrine release, and heart, emphasizing the neurohormonal pathway. We then transition to methods of milking, though specific techniques are not detailed here. Alveoli are described as grape-like clusters. Each alveolus consists of a single layer of epithelial cells that absorb nutrients from the blood, transform them into milk, and discharge the milk into the central cavity. Surrounding these are myoepithelial cells which contract during letdown to eject the milk. Milk is released from the alveoli into ducts that carry it to the gland cistern. Between milkings, about 40% of the milk is stored in the teat and gland cisterns and major ducts, while the remaining 60% is retained within the alveoli. Around the time of calving, the secretory cells of the alveoli begin producing milk. The large surge of prolactin during parturition signals the start of lactation. Prolactin, insulin-like growth factor, IGF-1, and growth hormone are all important for milk production and maintaining lactation. Milk letdown is explained in depth. During secretion, the alveoli, ducts and cisterns fill with milk. While milk in the cisterns and larger ducts can be easily removed, milk in the smaller ducts and alveoli requires ejection, an involuntary neurohormonal reflex. Stimulation through udder washing, teat manipulation, or calf suckling is necessary to initiate this reaction, with calf suckling being particularly effective. The letdown mechanism involves nerves carrying stimuli to the brain, which then signals the pituitary gland to release oxytocin. Oxytocin acts on the myoepithelial cells, contracting them to force milk out of the alveoli and smaller ducts. This process takes about 45 to 60 seconds after stimulation, with maximum effect occurring around 7 to 8 minutes. Prompt and rapid milking is crucial for maximizing yield, and stress can inhibit oxytocin release, underscoring the need for a calm milking environment. Thank you for joining Class 11 on Moo Techie. We hope this detailed breakdown of the mammary system and milk production process has been informative. If you found this session helpful, please support us by liking, subscribing, and hitting the notification bell for more expert insights. Keep learning and innovating with Moo Techie, where science meets dairy excellence.